welcome everyone. Welcome to this webinar on design process for regenerative buildings. My name is Marloes Reining and I'm a director of the Regenerative Collaborative of South Africa as well as Solid Green Consulting. So we're going to kick this off and I'll be your facilitator for today. All right, so we have a sponsor for today for this session, which is Solid Green Consulting, and I happen to be the director of that and decided to sponsor this session. Solid Green is a sustainability consultancy for the built environment. We focus on green buildings and assisting project teams with anything related to sustainability. So if you want to do a regenerative building or even an XA or Green Star or anything related to sustainability and buildings, just reach out to us and we can assist you with that. On the Regenerative Collaborative is a voluntary organization who is concerned with driving advocacy and driving awareness around regenerative buildings in South Africa. You can follow us via Facebook or via LinkedIn. What we do on a monthly basis is we organize these events, these webinars, and creating like a database of really interesting webinars and really creating awareness around regenerative buildings. If you want to join us or volunteer with us, let us know, reach out to us, and we'd be happy with any help that you can assist us with. All our previous webinars that we've been doing are available on the Greenet website. So go to www.greenet.co.za and go to the courses, and then you'll find all the previous events that we've been having in the last 2 years. It's already 2 years. So there's a lot of information and webinars available for CPD points. Again, if you have an idea for the next RCSA webinar and you want to win 500 Rand, please reach out to us or follow this link, and I'll drop the link into the chat box a little bit later as well, and provide us with your idea for a webinar, and we gladly take that on. Today's webinar was the idea of James Jobert, so he will be getting his 500 Rand this month. All right, but let's go back to the topic of today, which is the design process for regenerative buildings. And we have 2 engineers presenting to us, and I don't think they need much of an introduction. We have Chilufya Lombe and Francois Retief, and they're probably the 2 most experienced and most knowledgeable engineers when it comes to sustainable buildings. So we'll first have Chilu presenting on how we need to change or what needs to change in the conventional design process to, even start thinking about regenerative buildings. And Chilu is a mechanical engineer. He's got huge experience with simulations and modeling. He was probably one of the first ones in the country that did all the simulations for the Green Star buildings. And he will be presenting to us just now. And then after that, or maybe they're even gonna start talking with each other. I don't know what they've cooked up for today. But after that, Francois Retief, he's the founder of Sow and Reap, and also has extensive experience with regards to energy performance of buildings. And he's been working in the green building industry for most of his career. He's worked for the RCSA and now running his own consultancy. So I'm going to hand over to Chilu.
Thanks, Marloes. I think that's the first time I've ever heard you say my full name. Thanks, everyone, for joining. This is always an interesting platform to have these discussions, especially as we kind of go into this new era of buildings. Just to confirm, Marloes, you can see my screen?
I can see your screen. We can't see you,
We can't see your face, Chilu.
Is that a prerequisite?
Come on,
is.
Give us a wave.
Okay. I guess onto the topic of the day. I hope Francois and I will do a good job of making it a non-technical discussion, but just talking about the key concepts that are really important on this journey. So I think a lot of times some of the definitions around sustainability, not everybody has the same background or understanding. So we always just like to start out with, why are we, regenerative buildings? What are we regenerating, and what is the impact in particular between energy and carbon? So quite simply, when we operate buildings require what are called indirect emissions, in the sense that we are purchasing power from Eskom, and Eskom is generating this power in an inherently unsustainable manner. So when we're talking about net zero or regenerative buildings, we're always talking about offsetting those carbon emissions, and in the case of regenerative buildings, actually giving out more than you would generate. Now, the biggest takeaway at the moment around this, how do you design these buildings? People always want to start to talk about the nuts and bolts and what goes in there. And what is really important is the idea of this integrated design process, or process-based design, meaning that we don't start at the end and work our way backwards. We have a systematic approach where we set targets for what we are trying to achieve, and we'll talk about what those targets might look like. And then those targets are related to, and then within those targets, we look at the opportunities that the climate presents itself, or the opportunities or the challenges from the climate. And then what is really important, and which is, I guess, a big focus, is optimizing these buildings. So looking at designing the buildings to really high standards of passive design. And that's generally led by that generally involves an architect and supported by someone like ourselves, doing the energy modeling and looking at how this building is really going to perform before you overlay any engineering. And the idea is that with your building being as passive as possible, or passively designed, then you select the right type of technology to match. And then you would look at your alternative power. And then what is really important is optimizing operations. All we are doing in the design process is giving a building the potential to operate in an efficient manner, but it doesn't necessarily mean that's how it will be. So very often as a design team, we stop when the building starts, and then it becomes someone else's problem. So in this process, the operations and continuous optimization is really what is important. Very often, if you say a regenerative building, a green building, net zero, everybody starts with how much PV do we need, and not how good our building can be. This is the idealized situation. I think in my case, as much as this is what we always preach, until this idea of regenerative buildings, net zero came along, I think possibly in the last 10 years, we've had maybe 2 projects that really went through this in the systematic manner, where no decisions were taken until you got to a particular place. Francois, I don't know what your experience has been in terms of an actual process where you're not starting on a building and they are digging the hole.
Yeah, thanks, Chili. I think I was about to ask you that same question as to how you get it right. How do you get it right to enter the conversation early enough that you can set targets, analyze climate prior to that concept design? And it's an ongoing challenge with us, and what we're finding is that the relationship with your clients, for us, it's only really working out generally on projects where we've built a relationship with a client, where the client has seen the benefit on a project, even though we may have come in a bit too late. And then on their next project, they see the benefit and they bring you on early enough. I do think that maybe the net zero drive now is forcing at an organizational level targets to be set that are now allowing us to set our targets on each building, where previously that organizational target wasn't there, of the 2030 goals and the 2050 goals. But it's a huge challenge for us to get in early enough on projects to help set those targets.
Yeah, I think as we go into the next ones, it'll become apparent is that before this, forcing a change in the industry could only come if the targets were moved further out. So we're going to see now moving forward more and more that if everybody's going to realize that if this is what is going to be our target, and it's not really going to be negotiable. You know, South Africa, there's 4 cities, Johannesburg, Tshwane, eThekwini, Cape Town, that have all signed up to be net zero by whatever year it is. Most organizations have got some kind of net zero strategy or targets, and that really means that as they start to see what do we need to do now, what is the most important part, it's going to be process and starting early. So I think it's been a long time to wait, but I think the industry is now really just catching up to what we've, you know, the need is now there, and we'll see now around these targets. So the first couple of, yep.
Would you mind flipping back a slide quick? Just one point to make. What I'm finding also, last comment hijacking your section here, is the link between the start and the end is starting to become way more important. And I know you guys are doing a lot of work on this with Solid Insight, but we see now with energy performance certificates hitting the scene, buildings have to achieve a certain performance once they're operating. So now as we develop buildings, we're developing with a goal in mind, you know, because we know we need to reach a certain performance at the end. So I think the link between the start and the end is becoming more and more important as well.
Yeah, no, definitely. I think, you know, the one part is this idea of you set the target, but yeah, setting the target with an eye to the fact that you have to actually achieve it in operation. So it becomes a completely different thing. You know, people want energy efficiency. They want to be on this journey to net zero. So it's not longer a case where we can say it, but we don't really know how it happens. And feeding back on real world performance into design processes is going to be another important thing. So maybe now we should have like a little arrow that goes back from optimize operations back to set the target for the next building, you know? So in terms of these definitions and what is...
Sorry, Chilu, can you go back to one slide? I have a question. So you like the title of this slide is integrated design process, which I would imagine mean that like everyone around the table would work together to get all these things done, right? Or can it really be just the architect to reduce the loads and the engineering team to do the purple icon?
So when we get into some of the detail, we'll see how, you know, it's like you've got the main protagonist, as it were, you know, but you'll see where the integration is. And a lot of it comes from, you know, there's the integration around setting the targets, and then also around the decision making to achieve your goals, you know. So you'll have the architect, you'll maybe be doing the energy modeling, you'll have a client, and then you will have certain decisions to make as a design team. But there is someone who is ultimately responsible in each stage, even though it's going to be a team effort. So for example, when you are doing the load reduction process, you will have your mechanical engineer involved because he needs to understand that this building is quantifiably better than the last one, so that when it comes to his turn to do the design, he's then knowledgeable about what has happened before that, because previously these steps happen instantaneously. Someone is sizing the PV, someone is designing the building, someone's designing lighting and air conditioning.
And I think your role, Chilu, or my role in the project as a sustainability consultant, I've found is almost becoming that iterative link. So between architecture, we then pull the link back against targets and check it. During engineering work, we'll pull the link back to targets, back to architecture. The same with renewables, where previously in complete silo, if that check against targets and against other disciplines isn't happening, you find that engineering is sizing to a certain, you know, their certain calculations. Renewable energy is using a different calculation methodology. Architecture is using a different methodology. So I think our role is to connect those dots, maybe.
Yeah, definitely. And, there has to be someone that from this process also into operations, because when the buildings are not performing as expected, and nowadays it's kind of like that person who was guiding this process is the first one you sort of start to ask. So you need to be able to understand what was the potential and what is the reality. We've been doing some really interesting work looking at some of these buildings and seeing how it's just operations are really letting down the concept and the idea previously of how the building was meant to be. So in terms of this target setting, so we'll say we want a regenerative building. And what does that mean? It means that we want a building to use less energy than we can produce from renewable energy on an annual basis. So the definitions when it comes to regenerative buildings or net zero, it's actually very, very simple. Either be neutral or give back to the grid. So that means that you've offset yours and a little bit of somebody else, and they're in the definition of being regenerative. So the definition is very easy, but the application is not. So Francois mentioned earlier the EPCs and legislation that has come in place, which means that real world performance of buildings is being measured and is being reported, right? So that means that when you've got a Green Star building, for example, or something like that, whatever you say in design that you're going to achieve, it's actually going to be measured in real life. The idea really now is that as we go along, if you said that why are most buildings going to come out and on the EPCs? If you had to be a regenerative building, you have to first of all reduce your energy use significantly, come out as an EPC-A before you can be regenerative, because the amount of energy that you're offsetting is directly proportional to whether or not you can do it. Francois, do you have any comment on that EPC one? I know you're doing a lot of work on EPCs at the moment.
Yeah, thanks, Chili. So we are facilitating the EPC process quite a bit at the moment, not necessarily issuing EPCs. And look, the EPC process, I think there's a fair amount of criticism at the moment, it being new and the process being new and the standards being new. But if we zoom out to the intent, I feel, of EPCs, I think the intent is really good, and I think the potential impact is going to be massive in our industry, because at the end of the day, if you look at the car market, liters per 100 kilometers, everyone knows that concept, everyone knows how to ascertain a fuel efficient car versus not. And what EPCs are going to do in the longer term is kind of set that standard language. So at the moment, the benchmarks are not in the right place, and I think you'll show that. But I do think the process of understanding our buildings through EPCs, through energy performance certificates, is a really noble, process, and I think it's something that we should all support.
Cool. Thanks for that little filler back now. Yeah. So if we're looking now at some of the real world performance, the average Green Star rated building, and of course that's a very general term, because you can have a building that is 4-star, 5-star, 6-star, got 8 points in the energy credit, or got 20, or whatever the case is. But we're seeing them between 150, 180 kilowatt hours per square meter per year. The fact that Green Star is also a base building rating, and this is overall, also impacts that, because we see a lot of different behaviors within tenancies that drive the goals. But nevertheless, you can see that overall, what is really important for the regenerative buildings is this very, very high level of energy efficiency. So if we are looking at real world performance and how to get this, whether it's in design or in reality, is to say, was this building quantifiably more energy efficient than anything else that I have done? And so a 60% reduction in overall energy use is quite significant. And then also your targets, and Francois alluded to it with the EPC benchmarks, is that if your target setting is unrealistic, then it makes people not have faith within the process. So, for example, the EPC benchmarks when they first came out were benchmarked to SANS 2011 numbers, and now they are benchmarked to the latest SANS numbers. And so that means in terms of real world performance, there is this significant difference between what would have gotten you a particular EPC rating before and what one gets you now. So, for example, if in the old terminologies, you were a C-rated building, 180 kilowatt hours per square meter per year, remembering that the average Green Star building is sitting kind of roundabout here. Under the new figures, it makes you a G rating or thereabouts. So that really means that, you know, EPCs, the idea of EPCs as a target or benchmark is really good, but I think the previous ones were maybe a little bit better to go along with, because it correlated a lot with what we were seeing as the potential of buildings, and now it really makes it quite difficult. And the best way to visualize this is that previously, when we were trying to offset an A building on the old ones, you know, on the new versions, that is equivalent to a D rating, which on paper means that it should be easier to get regenerative buildings because our buildings will be so energy efficient, but it's just becoming a little bit academic in terms of the correlation to real world performance. So target setting doesn't have to only be according to energy. There are other metrics that are required in terms of how a building performs, and one of them is natural light. And because, especially on commercial buildings, this is always where the biggest issues lie. So target setting around natural light would be on the left-hand side, we have a metric called daylight autonomy, and that's just saying how often can the lights be off across a building in the space. So this metric is measured by, it's called SDA, Spatial Daylight Autonomy, and basically anything that is green and above means that you've got a really high percentage of the year when you can have the lights off. So this is looking at daylighting annually and not at a moment in time. And the one issue with daylighting is that as much as you have a minimum, there's also a maximum. So you want an even distribution of light, which is linked to the geometry and the design of the building, but you don't want a case where you've got very bright light, because that leads to glare, it leads to issues with heat, and very often we see a lot of these buildings that were designed for natural light and the blinds will always be down because now the spaces are too bright. So on the right-hand side is a metric called solar exposure. So we might have a case where you've got a lot of light, but you've actually got too much of it. And when we're going through this process, you would set parameters so that you say, we want light, but we don't want heat. So good light might be at 40% window to wall ratio, but heat might be at 80. And where we've seen previously the aesthetic rather than the functional use of the space being the driver, we're going to see the functional elements being more and more the driver, where it'll be pretty difficult to justify buildings that do not operate within a particular spec. So I normally use this slide at the end of a presentation or right at the beginning, but for this particular one, the middle was quite good, because this is a really key concept that we all need to understand about where we are and what is possible. So this is a quote from Paul Hawken, who was a speaker at the GBCSA a few years ago, has a couple of books on sustainability. And it says the first rule of sustainability is to align with natural forces, or at least try to not defy them. So that as a segue into when we look at the opportunities of climate, and I've just used Johannesburg here because I think Francois will talk a bit more about this in detail. But if we look at Johannesburg, the average temperature in Johannesburg is 17 degrees, right? So if we have a comfort temperature range being between 22 and 26 degrees, that means that if the average is 17, your overall across the whole year is that your net energy is in raising temperature and not lowering it. We had like a really bad heat wave a week or two ago, which, you know, everybody will be remembered. It will be in the high 30s and all of that. But across a year, those type of days or hours are really statistically irrelevant because it'll be less than 1% of the time. So regenerative buildings cannot be climate defiant, and that is, for me, one of the key elements of wherever we're trying to do these things. We say, is this defiant or in line with the climate that it is in terms of the building's design? So when we go on to the reducing loads phase, this is where we are using modeling for design to improve the passive design of the building. And that's where we try to answer questions in a way that has got, you know, numbers and real feedback. So if we're saying, is there enough daylight? First of all, we've quantified what is enough daylight and for how much of the building. So when we run the simulation, we'll say yes or no. You know, how much insulation really do we need? What is the impact of thermal mass? All of these things which a lot of people have got an intuitive feel for and some don't. We would put numbers across and put some kind of decision-making rationale so that you can understand what works and what doesn't. And the importance of targets is that they tell you when you can stop during your optimization process. So if we took that building before and we said we had a performance benchmark around daylight autonomy and around solar exposure, we'll know that the initial was not meeting the requirements because the annual solar exposure was not being met. So now if they added shading to the north, assuming north is straight up, they would reduce the amount of light at the perimeter, but be within the target, and then also reduce the amount of direct solar exposure. And this is essentially why you go through this process and why you have targets. Sometimes you find that without a target, you're not going to know when to stop or when a solution is good enough. So running at net zero, or I suppose in this case we should update the slide to being regenerative, is the more time in the year that you can achieve this balance with nature, meaning that you are running a building primarily with natural light, you are keeping the conditions indoor comfortable using either natural or mechanical ventilation, meaning that you're not applying additional energy to reduce or increase air temperature. And of course, you have the building running on renewables. That's when you are going to have these. That's when you're going to have the ability to have a building being regenerative. And what this basically means is that more things should be off for longer times of the year. Your lighting should be off, your main air conditioning should be off, and the building really is going to be operating mostly on the actual functional requirement that it has. So there'll be people there with computers or whatever equipment that is needed in the building that they're doing. So this is another real key step, and it really goes along with the idea of trying to align with nature. If we're trying to have buildings that are powered primarily by the sun, it means that they can't be inefficient in a manner that requires too much energy. And then the other concept is, you know, moving air. And a lot of times when you are on a project, everybody looks to the mechanical engineer to say what systems are going to be energy efficient enough for what we need to do. And the reality now is, because we want things to be off, we also know we need ventilation within the building. So decoupling cooling from ventilation is a key concept, because that means that whenever outdoor air can be used, instead of the cooling system, you run that. So that means that in a building, you might find that fresh air being put through the building means that your main AC system can be off from 0 until 10 a.m. And then that's when you need to start cooling. We generally see in a lot of commercial buildings that we're not designing with openable windows, but a lot of times, even if you do design with openable windows, you partition the buildings and you don't always have a direct access for air to be able to flow all through the building. So that's why you will decouple or separate cooling from ventilation, such that when a building can use ventilation only to keep the space cool, you will do that. And of course, we'll know that at some point we will need a bit of heating. But if we've kept the aircon off for higher percentages of the year, then that means that we are closer to this idea of the regenerative buildings.
Please feel free to raise your hand if you have a question. We can always unmute you.
Good day, everyone. Mr. Chilu, you spoke very eloquently about the regenerative processes, and it's very interesting because I am actually an entrepreneur who runs a company called BioLandscape Solutions, which concentrates on biophilic design concept. I don't know how much are you aware of the biophilic concept, but I would like to actually advise me and a young entrepreneur that is interested into understanding more about the regenerative processes. How can I actually align myself for more exposure, probably companies or organizations, as much as this regenerative processes, they combine a lot of professions?
Cool. Yeah. So I think, there's a lot within the industry around changing how we perceive the way we can be in buildings. So with biophilic design, I think it encourages this return to nature, right? So that industry then starts to grow, or you have someone who is advising within that. It means that you can have a building that has more natural elements, and also how we can get the message across to increase the occupant connectivity to the natural environment, right? Now, these are very technical concepts that we're talking about here, but there's a softer side that has a larger impact, which is how you impact the people that are in the buildings and why their expectation is such that it is. If we're talking about aligning with nature, when it's 33 degrees outside, should you be demanding 21 degrees inside? Because at home you'll be sitting in 26 degrees, but now when you are in a different environment which doesn't feel like a natural environment, you have a different expectation. So it's something that literally had to think of this answer as you were talking, because I've never really thought about it. But this is where the industry is now, where there's going to be all of these things that before you couldn't get your foot in the door. But now these are the things that we need to be looking at, and these are the things that need to be influencing us over and above the technicalities that are kind of like the first steps we always think about.
Thanks, Chilu. There's a question in the chat box from Matthew. How cost effective are heat recovery ventilators?
So cost effective is always relative, right? Because people often don't do the right type of, like for like comparisons. So for example, in a residential setting, a lot of houses, and it's always interesting because you go to these like high-end houses, lots of glass, now they're air conditioning the spaces, right? But there'll be air conditioning spaces which they primarily occupy at night. And at night, now this house is hot and you're running an air conditioner. If you had a heat recovery ventilator, you would have no air conditioning. You would just be using that to provide fresh air rather than normal cooling. So for those that don't know, a heat recovery ventilator is basically a very fancy fan that can bring fresh air in from outside, and then it pulls your hot air out. But when it's pulling your hot air out, depending on the conditions, if outside is hotter than inside, it'll use some of the cooler air inside to cool the hot air coming in. But it's basically, again, a fresh air system. Now, when you are looking at, say, maybe a commercial building and you're trying to make use of that, it would be very effective if you could take cooler air that's inside and you're passing it out with and then the hot air that's coming in is much colder. So that's where all these elements of integrated design come in, because they don't work if your building is not designed well from a passive perspective. So I would say that any solution that is encouraging fresh air and designs around that is always going to be useful, and the cost effective as if you are doing the correct type of comparisons for the benefit.
Great, thanks, Chilu.
Cool.
Marty, do you want to be quick today? Let me unmute you. Yep, go for it.
How's it? Am I getting a reputation?
No.
I'll try and be
You're
quick.
not getting, you already have.
I don't know whether the answer is going to be that quick, and I was cut off a few times along the way, so I hope no one's answered the questions. But the whole thing with fresh air, outdoor air, what about noise and pollution and all of those other aspects for a building that's in the CBD of Johannesburg? There's also, crime and these other things. So, there are noble goals, but practically, how do you deal with things like pollution outside, lots of vehicles driving past, carbon monoxide, all of these other wonderful things that are going on outside our buildings?
Yeah.
But those elements are already accounted for, right? You by law, you have to have a fresh air system. You will filter, you will do whatever needs to be done. And I think those elements, for me, maybe it's the mechanical engineer coming out. Like, I prefer mechanical ventilation to opening windows because it's 100% controlled. You know what's coming in, you know what's happening. But that element, it's a legislative requirement. You must provide fresh air. All we're saying is separate it so that if the fresh air is enough, the air conditioning can come off. So as a concept, it's a very simple thing. We're just mimicking natural ventilation.
But
Yeah.
what I'm trying to say is that mechanical ventilation goes through filters and all those things. You can't have a filter on every single open window.
Yeah.
Yeah, but when we're not talking about opening windows. So we're saying use that mechanical ventilation system that is there. The only difference is that your fresh air can enter the space directly and doesn't have to go through a fan coil unit. That will mean that the fan must be running. That'll mean the chiller must be running. This is with the assumption that windows are closed and you are just using the same fresh air system.
Okay, I was meaning actually opening windows, but that's cool.
Yeah.
Thanks.
Well,
Yeah.
Marty, if I may add there, I think Chilu said something earlier which is really powerful, and it's about designing for the core. I can't remember how you put it, Chilu, but you're designing for the purposes within this building. So do we want fresh, do we want air? No, we don't want air. We want a healthy environment, Do we want air conditioning? No, we don't want air conditioning. We want a comfortable environment. So I think the core is you start with that point, and then every site has its circumstances that dictates the design. So in some instances, to get your healthy air quality, openable windows is the right solution, But in other instances, to get your healthy air quality, mechanical ventilation, filtration will be needed in order to deal with noise, pollution, etc. So it's really not a one-size-fits-all box, but if you're designing with the purpose of the building in mind as the core, then we get the right outcomes.
Yeah,
Thanks.
I think just to add on that, Francois, that's why the idea of the process is really important, because we gave two examples of like your targets or goal setting, but in that particular area, you might have a couple more elements that will lead you to the right solution. So, a key takeaway is that if you have a process-based design, you always come out to the right solution, but it might not necessarily be the same solution each time. And the only thing that should be consistent is the process being followed.
Cool. So I'm going to tag on to Chilu now. And I thought I'd just circle back to this and the previous comments around biophilic design. I just do want to mention also that regenerative can apply to a host of environmental issues. And obviously right now we're focused more around occupant comfort and around the factors that influence energy. But if you look at occupant comfort from a biophilic perspective, the same diagram can apply. The top two circles are how can you first maximize your access to natural ecology that your site provides? How can you use natural ecology that you're given? And then whatever you can't get from there, you can bring in the way that renewable energy is brought in. You can bring in your ecology into the building, introduced. So the same kind of thinking can apply to all different aspects of regenerative buildings. our focus is mostly sort of energy and comfort today. So Marloes has asked me to kind of talk a little bit about how does this actually play out on projects. So the first scenario, I thought I'd look at design for comfort. So as we were saying, what is the goal here? And the goal is not to have an energy efficient building. Your goal is to have a comfortable space for humans. You know, that's why we build the building in the first place. And then in order to achieve that goal, how do we do it in a regenerative way? So thermal comfort, some of you guys may have heard this spiel from Chilu or myself before, but thermal comfort is not just about air temperature. You know, there's a host of factors that play into whether we're comfortable thermally or not in a building. Some of them, you know, are like your metabolic rate and your clothing are somewhat less in control of the designer, but it's still a factor that the designer brings into play. So a 70-year-old female and a 20-year-old male, you know, have very different thermal comfort requirements. Humidity is a big one, and that's the climate that you're in. And then the three I want to talk about most is airspeed, air temperature, and radiant temperature. So one of the ways that we look at assessing comfort in a building is the adaptive comfort method. It's an ASHRAE standard, ASHRAE 55, that looks at this method, and it basically balances these three metrics. So what it says is you don't have to necessarily bring the air temperature in a room down to 21 degrees to be comfortable in summer. There's a way of calculating it, but depending on what the outdoor temperature is, your air temperature could be high. It could be 28 degrees, and you could still be comfortable because maybe you've got cool surfaces around you, radiant temperature. So maybe you've got nice thermal mass on your floor or your walls, that nice cool radiant temperatures around you. Or maybe you've got good airspeed, so you've got good air changes, whether it's natural ventilation, mechanical ventilation, ceiling fans. You know, you can play with these three factors to get your comfort met. And the most energy intensive usually is air temperature, because you're mixing up all the air in that room and pulling it down to 21 degrees. But that's only one tool in our belt. So what we're aiming for is how often can you get this comfort without the air conditioning being on, is really our goal. So Chilu mentioned earlier, you know, that it's not just about the efficiency of systems. We're not going to get 60% reduction in energy in buildings with more efficient air conditioning systems. We're going to get there by turning the air conditioning off, you know, for the majority of the time. Okay, so basically the point is indoor air temperature is only half the story. So if you're sitting in a park, these two couples, the air temperature around them is exactly the same, but you know who's sweating and who's not. So indoor air temperature is only half the story. Airspeed and radiant temperature especially are super important. And you know, believe it or not, we are designed to live on this planet. We're designed to live in this environment, in this natural environment. And this graph shows a study done by the CSIR, by Dirk Conradi. And it shows what percentage of the year could you be comfortable in a building in our cities without heating and cooling. And it shows that technically in Joburg and Cape Town, you know, more than 80% of the year, you shouldn't need heating and cooling if the building is designed ideally in terms of shading, you know, etc. So we should be starting from a base of, okay, how do we get to a point where we only need to turn the aircon on for less than 20% of the year? Or maybe we just accept the fact that for 15-20% of the year, it's a bit warm, you know. So here's a sample project. It's a very simple, small project. It was a local government project we worked on, office space, event space. And the basis that we started with was a fully air-conditioned design. The building passively is designed really well. It's north facing. It's very well shaded, and we started off looking at, well, we looked at kind of sun penetration, etc., and climate, and moved into comfort. And we said, okay, well, what is the thermal comfort looking like without air conditioning? So we looked at what happens if we take the air conditioning out and we run natural ventilation models on this building. What are we looking like? And we found that it was doing okay in terms of the ASHRAE 55 adaptive comfort standard. It's doing okay for a large percentage of the year, but you know, a lot of these spaces you still would need to condition. It's not acceptable to be sitting at 60% in your offices. But then you break it down seasonally. And for this site, and because it was so well shaded, and because the materials and construction, you know, had a lot of thermal mass, we found that in summer this building was actually very comfortable. There were a couple of areas where we could optimize shading a bit better, boardrooms or open plan offices, but in general, this building doesn't need cooling. As Chilu pointed out, you know, heating is the issue once you've shaded your building properly. So if we can deal with the shading, we remove the cooling completely. But we did then have to deal with this issue that the space is getting too cold in winter. We also then are able to use the models to compare your fabric, and in this specific case, you know, wall insulation proved to be a better choice than double glazing. We had quite small glazing ratios, and you know, we're not sitting next to a lot of facades. But essentially, we're going with wall insulation over double glazing in this scenario. You know, finally, I mean, Chilu spoke about daylight, but we run the daylight analyses as well, and ensure that our daylight performance is good in the building. The point I'd make, though, is through that exercise, you know, what intuitively felt right, conditioning office space, conditioning event space, once analyzed for the specific site, completely changed. And so we ended up with no air conditioning in the building, natural ventilation mostly throughout, single glazed low E with wall insulation. And we, instead of the air conditioning, we went for a low energy radiant underfloor heating system. So a hydronic underfloor heating system, which is a lot less energy intensive than the air conditioning, because we wouldn't have the fans, etc. And the temperatures, the temperature difference is much less. And ultimately, the project is targeting net zero operational carbon, so as part of its Green Star certification. And you get there by removing things, by turning things off. Obviously, there's a lot of other work in, you know, lighting that went in, and there are renewable energy systems. But the huge savings came from turning things off, from not having air conditioning in the first place.
Francois, just before you go on, the natural light results were quite interesting. Do you remember offhand the overall window to wall ratio of this building?
I don't offhand, but I know that this multi-purpose hall up on your top right had quite high glazing ratios. The offices, on the other hand, didn't. Down on the bottom, on the south of your plan, the multi-purpose hall did have quite high glazing ratios. What we did, though, was we made use of clear story glazing in there quite a bit to get the daylight penetration in.
Okay, cool. So it's really interesting now, because, you know, based on these targets, sometimes you find that there are particular decisions that have to be made that before could never be made. You know, like at the moment we've got a project where we've said we need a 15% reduction in glass, wherever it's going to be. it needs to be 15%, you know, like that would have been unheard of in the past. And I think the outcome on the external walls is also particularly important, because that's an outcome that happens when you follow a process and you get your results, as opposed to kind of thinking, well, this is the knee-jerk thing that if we're going to do this, we must do that element, and it's linked to, you know, what the climate is like and all of that.
Exactly. I mean, you would know in your typical commercial office building, double glazing is usually, you know, a very good go-to, because you're sitting with hot glass and all that kind of all those sort of issues. In this specific case, didn't make sense.
Francois, just before you go continue, Alana has a question. Did you need to provide heating in the end? And if you did, what type of heating was used?
We did, Alana. We put in underfloor hydronic heating in certain zones. So that doesn't really bring the temperature up to, you know, to 20 degrees, but what it does is it just heats that floor surface. So we took advantage of the radiant heat on the floor surface to bring comfort. So it's essentially just water circulated through pipes in the floor and heat pump for that heating.
Right, thank you.
If I can ask another question quick.
Sure.
In terms of the whole thing of thermal comfort, as you mentioned, that's going to be very different for different age person, gender person, even other aspects affect this. In terms of like well ratings, etc., as well, you start looking at more granular control for per user and all that sort of stuff. You know, when the original design things that used to talk about design parameters of 22 or 21 plus and minus 1 or 2 degrees, with the increasing heat that we are having, is that still what we're aiming for? I mean, I personally feel comfortable at 17, so your Joburg scenario, for me, year round, if it stayed at the average, I'd be happy. But how do you actually deal with trying to get so granular and not having systems, if you know what I'm saying?
Yeah, I do. So Marty, we had this fascinating thing through COVID now and post-COVID. Every time we do presentations or surveys, we try and ask people, and maybe I'll ask you the question, so pre-COVID, when you were working in the office, and generally office spaces was a conditioned office, and COVID and post, people have been working from home, and generally that is an unconditioned space. So we asked people which was more comfortable for you thermally, you know, your air-conditioned office or your unconditioned home. And almost every time the results show that most people are more comfortable at home. So this is really important, and we need to question what are we doing here? You know, we're conditioning these spaces to 21 degrees, thinking this is what makes people comfortable, but actually the results are showing differently.
But it's not only the temperature. So I mean,
exactly.
I would definitely say home for me, and that's one of the main reasons that I'm happiest working at home, is I've got a window open right next to me. I've got a fan. When there's not load shedding, the fan can work as well. And my dress code at home is very, very different from my dress code at work. So, you know, it's very minimalistic. So it's according to, and I was uncomfortable at work because of the dress code and all those other things, even though they were trying to maintain 21, which they didn't do. It was more like 24, and I was dying.
Yeah.
So
yeah. So I think my point, Marty, is it's when we rely on air temperature alone that we kind of removing control from the individual occupant, and then you know that's an issue. So the beautiful thing about natural ventilation and openable windows is you also have that it's giving the control back so that people can open a window or close a window. The same with air speed is a very interesting one, and whether you can get, you know, fans in the work environment that has that have more local control, or whether your air outlets, you know, in a displacement ventilation, underfloor ventilation, where the occupants can adjust those. These are interesting concepts, but when you go for central systems that set one temperature for everyone, it is a challenge. You're always going to end up with disappointed people. But even in the best case, you're going to end up with people that aren't happy with the environment.
Yeah, so Marty, just to add on that, a lot of times when the temperature you would like, it's like the set point is 17, but we don't really know what the temperature is. But it's always worthwhile pointing out that from a technical perspective, if you get the absolute perfect result with regards to how you calculate thermal comfort, you still have 10% of people dissatisfied. So you unfortunately might be in that 10%. But also this relates really well to the fact that the more stringent your targets are, or the more ambitious they are, then the kind of different solutions you're gonna have to end up with. And before, our targets weren't stringent enough to really force people to change. But now it might be that an organization would have to say, listen, we've always required people to be at work in a suit and tie, but if we allowed them to wear a short-sleeved shirt and not have to wear a tie, the increase in thermal comfort means that we're going to get that last little bit that we're there. So a lot of the solutions that we're actually going to need moving forward, I think we haven't even thought up yet, because we haven't had to, firstly, try to achieve this in design, and then secondly, have to achieve it in operations. And then when you're not achieving it in operations, that becomes the only thing. Everybody forgets everything else. So the performance benchmarks and the actual performance is going to go above all else.
Yeah. I think if I can add one more example of innovative thinking around this that we're seeing, Marty, is space planning. So you also end up in this, through this analysis, you can identify and say, okay, that's likely to be a slightly warmer zone in the building. This is likely to be, temperate. That one's colder in winter. And you can zone your space planning accordingly, especially with, flexible workspaces nowadays. And if you're the type of person who gets very cold, the warm zone is going to be for you, and people can sit there, or your transient type tasks can be in those warmer zones. So we're super excited about actually matching these thermal analyses with space planning as well.
Francois, just before you move on, there's a question from Matthew on the heating system that was used for that case study. And the question is, what was the heat source for the hydronic system? And also, do you recommend ground source heat pumps for this system?
Thanks, Matthew. So in this case, it was an air source heat pump, and we found that to be, you got to balance the cost effectiveness, versus efficiency. And we found that to be efficient enough to be able to, run that with our renewables and still achieve net zero carbon. Ground source heat pumps, I haven't used them really in the South African context. I've worked in the UK where we made use of ground source heat pumps a bit. I've seen them used in the South African context, and you can achieve, good efficiencies. Your efficiencies are often better than an air source heat pump. But the question of whether the additional cost warrants it is what you need to look at for each individual project. I don't know, Chilu, if you've got another comment on that.
Yeah, no, definitely, because we've worked on Hotel Verde, which was the first commercial application of ground source heat pumps. So it goes back again to that target setting and the solutions for the target. So when we started that project, the client said, I want the greenest hotel in Africa, right? And he really wanted to be pushing the boundaries of what happens. And even though we did that, and we really threw a lot of tech at what was already a good building, the first thing to mention there is that with ground source heat pumps, vertical axis wind turbines, all of those things, the premium for everything around sustainability was only about 9 or 10%. But as a technology, I think, in a hotel environment, you'll probably find that it works well because, you know, when you have heating and both heating and cooling, because one of the issues with ground source heat pumps is that you need a balanced load. So if you're going to do only heating or only cooling, then over time, the effectiveness of the system reduces because you are only ever pulling heat out or putting heat in. And for those that are maybe not aware, ground source heat pumps are basically like your normal air conditioner that you'll see anywhere, in terms of having a compressor to heat or cool the building. But the difference is that instead of rejecting the heat into the air, the heat gets rejected into the ground. So you drill holes into the ground, and then you have your fluid going through there, and then heat exchange happens with the ground. And the reason that it is very energy efficient is that you have a constant temperature that you are rejecting heat to. So that means if it was 35 degrees, the air was 35 degrees, you need a lot of energy to push heat against nature. So that means that you don't really take, energy doesn't flow from the cold to hot, so that's why you need more energy to use a system that is using air for heat rejection. But your ground is at a very stable temperature, like a constant 19 or 20. So your effectiveness of cooling is improved because you are rejecting heat to a colder place.
Chilu, you promise we're not going to get too technical here, huh?
Well, you got to explain the concepts, though. Now everybody's Googling ground source heat pumps, so we might as well say it here.
Yeah, exactly.
I think we're doing well, though.
Yeah.
No question marks.
Hopefully. Thanks. So just to recap there on that case study, it's exactly this thing that Chilu was talking about. So I've repeated his slide here. We're maximizing the time that outdoor air is good enough for our comfort. We're maximizing the time that natural light is good for our comfort, and then the amount that we need to supplement those two are very small, and therefore we can meet it by supplying renewable energy. So that's really the process on that project. And in that case, it was primarily driven by thermal comfort. Now, scenario 2 is a bigger commercial project, retail project, where we started off from the perspective of daylight and lighting comfort. So large retail center with big horizontal roof lights. So you can see here horizontal roof light and also clear story along the edge of those roof lights. So it's pretty typical of what you'd see in large retail centers. And trying to understand, how do we optimize this? So Chilu had this slide earlier of how it's really important to get good daylight, to get lots of daylight, but also you don't want too much because of glare, etc. So we glare and heat gain. So we use the metric here. So we've used the methodology here called useful daylight illuminance. So what that is it looks at what percentage of the year, of the time, of your daylight hours do you get useful daylight. So in this case, retail circulation, we worked on 100 to 3,000 lux. So anytime it's over 100 lux, it's going to be useful. It's actually helping contribute to a brighter space. Once it's over 3,000, it's very bright, potentially glary, and potentially allowing in a lot of heat. So if we analyzed a before scenario with those horizontal roof lights, the daylight is great, but that green area where that horizontal roof light is only achieving useful daylight for, 50, 60% of the year. And the reason there is not that the daylight's not good enough, it's that it's too bright. We're getting glare under those horizontal roof lights. If you look at a scenario then where we removed, in this case, on this one, removed the horizontal roof light and just worked with quite a bit of clear story glazing there, the result actually improves because you got a much more even spread of daylight, and your daylight is not too high. Your lux levels are not too high. So, so we've refined, from a daylight perspective, refined the design of those through providing less horizontal and a bit more vertical. And then that obviously knocks onto heat gain. So in the before scenario, with a lot of horizontal heat gain in that passage here, we were getting like 90 watts a square meter of heat gain, even with good glass. So that needs cooling really in the peak of summer. In the clear story glazing scenario, you know, that's pulled right down to 20, 30 watts per square meter. This you can deal with using outdoor air only. So in this scenario now, again, you've removed the need for cooling and still achieving excellent daylight. So as I said,
Francois,
I mean,
sorry, Francois, I was trying to catch you in a gap there. I think this really illustrates quite well like the value of energy modeling, in the sense that if you had to look at those two concepts, you'll know that one is better than the other, but the modeling tells you how much better, so that if you've got a threshold, or you've got a you know, if you have to make a decision, you'll say, we'll accept this if it's going to give us a 40% saving. Now, you can't tell just by looking at it that it's going to give you a 40% saving. Well, I don't know, Francois, maybe you can tell now just by looking these days. But this now gives confirmation, and it also aids collaboration, you know, because you are able to give feedback that everybody can sort of understand and be part of the decision-making process. So being able to also present results in a way that can foster collaboration, I think, is something that everybody that has been doing energy modeling for a while has learned. You know, you'll have 1,000 pages of results, but you might only need one picture to get a decision made. And so you have to choose the right way of visualizing that.
Yeah, exactly. And I think the collaboration is key. So that integrated design process we spoke about earlier, you know, when we first ran this and presented it to the team, you know, the mechanical engineer came with potential solutions for extracting this heat at high level, etc. And the architect sat with how can they redesign the roof light perspective to help reduce that. And that's what got us to the end result, you know. So this process forces that collaboration in terms of both parties coming with solutions too. So the point here, something I wanted to mention as well, is that everyone always talks about the costs of these things. But I mean, massive savings were realized in reducing the extent of those roof lights, still delivering excellent daylight quality, and no common area cooling. Look, we didn't want to get to common area cooling, but there's potential savings there, you know, in reducing the cooling plants as well. So we need to look holistically at these costs, because if done properly, you're saving money here, not spending it. Again, exactly that same process, you know, we're maximizing the natural light, we're maximizing the time that we can use outdoor air, and therefore, you know, net zero becomes more of a viable target. Cool. So I don't know if there's, maybe I'll just give a couple of takeaways from my side, and then we can chat about questions. But the one which, you know, Chilu and I were chuckling about is use your technology in design, not in construction, you know. So these simulations, we're all working with really high-end design software packages, and the simulation tools are very accessible nowadays. So let's use that and set targets and assess against targets. Use that in design, put a bit more time in the design, and it can save us money in construction and save us effort in construction. So use the tech in design, not in the construction. Use targets to make informed decisions, as Chilu was saying before, and then we can choose low energy solutions to, you know, to take us where nature can't. And then the last point is, you know, what I was talking about, and Chilu was talking about, what is the function of the space? And comfort is queen. You know, people would say it's what we're trying to do. We're trying to deliver comfortable spaces. So optimize for that, and not just for energy. Chilu, anything to add from your side?
No, Francois, I think you've summarized this quite well. I think the first one is really quite important, that, we using tech, putting all your effort in right at the beginning, is really key to this, and everything else follows from that. And I think the definition of the beginning is often not really well understood. We always say, as long as this picture has been sold to someone, it's too late. These processes have to start before you go to sell it to someone. I remember doing a pitch to some architects to say, if we had to ask your clients if they'd pay extra for someone to sort of do this type of analysis and modeling, what would the answers be? And some people, like 10% would say yes, however many percent would say no. And then the real response is that clients think that has been done already. When they are shown a picture and they know that that there's a budget, there's all of these things, and they think everything is working. So that starting early, and when early is maybe the only other thing that it might add to that.
Exactly.
Okay, great. I think there's a comment from Matthew in the chat box, and I'm just going to read it out. I would say that the traditional commercial architecture process is poorly adapted to this sort of design. Clients are often unwilling to wait for the planning period, and often the drivers are different. However, you can put pressure on the client upfront. Maybe it can work. I think we all agree with it.
That's 100%, and I'd add on that it's not only that, but it's also the commercial arrangements provide like a counter incentive, because if we went and all fees are based on how much stuff goes in, so we're trying to put less stuff in, so we're asking everybody to work a different way, work harder, well, maybe not work harder, work a different way, and then in the end, the way that the fee structure is done is that they might get compensated less. So all of this is going to mean that there's every single part of our industry has to change in terms of what we do, not only from how we design the buildings, but even just how we engage with clients as a professional team and everything.
Great. Any last questions from the audience? There must be a lot of questions. Maybe we can just also repeat the question that you answered on the chat, Chilu, from Gemma, around the software that's giving you these outputs, and what type of softwares are there available to do all these simulations?
Okay, I did answer, but I guess it was a one word. The software, I guess, that Francois and I that we use is the same. It's called Design Builder. Design Builder is a front end for a simulation engine called Energy Plus. So Energy Plus is developed by the US Department of Energy, and it's really the most comprehensive energy modeling platform there is, with the challenge that it doesn't have a user interface. So if you are using Energy Plus natively, you are writing in code. So there's lots of software packages that then create a front end or a visual interface, of which Design Builder is one. And I think locally in the South African market for this type of work, there's really two packages that are being used. So Design Builder is one, and IES is the other.
Great. Any other questions? Otherwise, I'm gonna run through the last few slides. So the upcoming events for the webinars is next month. We're gonna talk a little bit about regenerative hospitality projects. Hopefully we can get a speaker about game lodges and some other interesting hotels. We haven't finalized the speakers yet, but that will come over the coming weeks. In December, we'll take a regenerative break, and then we will be back in January and we'll confirm the topic. Definitely, we're going to take this topic further that we were speaking about today to the residential space, so focusing mostly on residential buildings, and we will have two very knowledgeable speakers around that as well. Okay, so again, just a reminder, if you have a topic that you'd like us to explore and talk to you about more, let us know, and you actually stand a chance of winning 500 Rand. Just a thank you to our sponsors of today. It's a bit weird that I'm thanking myself here, but thank you to Solid Green for supporting the RCSA and providing basically the funding for your CPD points.
You're welcome.
Thank you, Chilu. And lastly, thank you to our speakers. Thanks, Chilu and Francois. You were great, and it was great to have you guys on board again. I remember I think it was the very first or the second webinar we did as Living Future Collaborative, and we also had a great webinar, but I think this one was very informative, maybe still a little bit too technical, but we'll work on that one. Thanks for your time and your presentations today. Just a reminder to visit the GreenNet website if you want to see any of our previous webinars. We are a little bit behind with uploading them, but I'm sure over December that will happen and we'll be up to date. And then lastly, thank you for attending. It was a great session and I hope you enjoyed it, and we'll see you back again next month, last Thursday of the month. Great. Have a good evening, everyone, and see you soon.
Cheers.
Cheers.